All right, folks, I just wanted to go over a few problems that were an issue on that test number 2. So we're going to look at some adding, subtracting rational expressions, solving rational equations, and then solving equations graphically. All right, so the first ones here that say simplify, these are actually adding and subtracting rational expressions. So when you're adding and subtracting rational expressions, the first thing you really have to do is find the LCD. Okay, and the mistake that people made with this first one here is they thought, all right, well, my denominators are 3x and x squared, so I'll just multiply them together and my LCD will be 3x cubed. But no, the idea with LCD was it was always take the highest power of any factor that you see. So when you have an x and an x squared, the highest power there is x squared, right? So, and then you got to take the LCD of all the coefficients. So the coefficients are just 3 and 1. So the LCD of the coefficients would be 3, and then the LCD of the x terms would be x squared. So the LCD in this case is going to be 3x squared. Okay, so then what you need to determine is, all right, so I'm going to write this now as a single fraction with my LCD of 3x squared, and now you got to determine what each one was missing. So the 3x was missing an x, right? Because to turn 3x into 3x squared, you need to multiply by x. So this x minus 1 is going to need to get multiplied by x. And then I have this minus sign in the middle. And now this second fraction, x squared is the denominator, it was missing the 3. So then this x plus 2 is going to have to get multiplied by 3. So you're going to have x times x minus 1 minus 3 times x plus 2 all over 3x squared, right? And essentially you're done. I mean, the only thing that you got to do now is simplify the numerator. So you distribute the x there, so you get x squared minus x. And then here, this is the advantage of writing it in this form as one single fraction. Now that I have it in this form, I can see that I'm actually distributing a negative 3, right? Because this was subtraction. So this becomes negative 3x, and then negative 3 times 2 is negative 6 all over 3x squared. And then I just combine the like terms here. So this is just x squared minus 4x minus 6 all over 3x squared. And this would be your solution here. This is now simplified. X squared minus 4x minus 6 over 3x squared. Now you might ask, well, can I factor that numerator? Even if it did factor, nothing's going to cancel with it in the denominator, so you can just leave it like that. But it doesn't factor anyway, because there's nothing that'll multiply to negative 6 and add to negative 4. Okay? So that's that one. Now the second one is the one that most people like. The reason being is, in the second one, the two denominators, x minus 4 and x plus 4, have no common factors. So since there's no common factors, the LCD is just the product of the two. So the LCD is just going to be x minus 4 times x plus 4. So what I do is I just write this again as one single fraction with the denominator x minus 4 x plus 4. And now I just multiply each numerator by what it was missing. So the first one, right, the 3, that fraction was missing the x plus 4. So I do 3 times x plus 4. And now here I have a plus. And the second fraction, which had the x initially, was only missing the x minus 4. So this is what I have. Now the problem is, some people on the test, they tried to cancel now. They said, oh, this x plus 4 and x plus 4 cancel, this x minus 4 and this x minus 4 cancel, so I just have 3 plus x over x minus 4 times x plus 4. I'm done. Can't do that. And the reason you can't do that is this plus sign. You can only cancel when you have factors to cancel. This is actually two separate terms here, right? So you cannot cancel here. This is the thing that Professor Tazy has in her video about killing kittens. When you do this, a kitten dies. So don't do this. right? So what you need to do here is not try to cancel right now, but actually do what we did over there and distribute. So distribute a 3, so this is 3x plus 12, and then this is distribute an x squared minus 4x, and it's all over x minus 4 times x plus 4. And now I just combine like terms, the 3x and the negative 4x. So the numerator is x squared minus x plus 12 over x minus 4 times x plus 4. And a couple people on the test thought that this thing factored and canceled, but x squared minus x plus 12 actually does not factor because there's nothing that's going to multiply to a positive 12 and add to a negative 1. People thought it was like x minus 4 times x plus 3, but then that would be x squared minus x minus 12. We needed it to multiply to a positive 12. So that just stays like that. X squared minus x plus 12 will not cancel. Okay, so that was the second one. And then the third one, and what happens with this is these ones like this are very predictable. The LCD, I repeat, the LCD is not going to be x minus 1 times x squared plus 2x minus 3. What you've got to do here is first factor that second one and write this second fraction as x minus 1 times x plus 3. Because now it's more clear that the LCD in this case, oh, they have an x minus 1 in common. So that's one of the factors. And the other factor is x plus 3. So the LCD is actually x minus 1 times x plus 3, which is really this. So that's really your LCD. So in this case, you're going to write this again as a single fraction all over x minus 1 times x plus 3. The first one, right, this 2 here, that was missing the x plus 3. So that needs the x plus 3. And then the second one, that already has the LCD, so that just stays as a negative 4. Well, as a 4, but it was minus, so it's minus 4. So that doesn't get multiplied by anything. So now you distribute the numerator again, so you have 2x plus 6 minus 4 over x minus 1, x plus 3. And then some people forced this because they said, ooh, look what's going to happen. I'm going to get cancellation after this. And then they wrote the numerator as 2x minus 2, but it's not. The numerator is 2x plus 2 over x minus 1 times x plus 3. So can you cancel, can you factor in the numerator? Yes, you can. You can write it as 2 times x plus 1 over x minus 1 times x plus 3. But x plus 1 and x minus 1 aren't going to cancel, so nothing happens here. So really, you could have just left, it in this form here, right? You could have left it in that form, or you could have factored out the 2 and then had it in that form. So really, in this instance, either one of those answers was acceptable, but it wasn't necessary to factor the numerator because nothing was going to cancel, right? But it's not a bad idea. Okay, so those were the adding and the subtracting of the rational expressions, right? Next, we'll get into the rational equations. Okay, so our first set of problems were rational expressions, adding and subtracting. The second set is going to be, and this is the wrong set, it's up here, rational equations. All right. Now, normally with most rational equations, you have to still worry about LCD, but in the first one that I have here, x over 3x plus 2 equals x minus 2 over 2x minus 1, there's only one fraction equal another fraction, right? One rational expression equal another rational expression. So whenever you have a scenario like this where it's just fraction equal fraction, all you have to really do with this is cross multiply. Now this is the only case that this applies in, right? If you just have a single fraction equal a single fraction, but here that's what we have, so you can just cross multiply. So you'd have x times 2x minus 1 equals 3x plus 2 times x minus 2. And now just multiply out on each side. So you got 2x squared minus x over here, and then 3x squared minus 6x plus 2x is minus 4x minus 4 over here. All right. So now again, this is a quadratic, so what you got to do is you got to set it equal to 0. So I'll subtract 2x squared and add x on each side to set it equal to 0. So I'll now have 0 equals x squared minus 3x minus 4. And now this is just a quadratic, so what you do is you factor it, and you say, well, what numbers will multiply to negative 4 and add to negative 3? That's going to be negative 4 and positive 1. So when you set each of these equal to 0, you would get that x equals 4 or x equals negative 1. And the only thing you'd really have to check here, I mean, you could do a full check, and check it exactly into the, completely into the original equation, but just make sure that that neither one of those make either of those denominators equal to 0. So the only thing that's making the first denominator equal to 0 is negative 2/3, and then the only thing that's making the second denominator equal to 0 is a half. And neither of these solutions are negative 2/3 or 1/2, so we're good, right? They're not extraneous solutions. Okay, so that was just cross multiplying. Okay, now the second one is the first one we have to worry about LCD, right? Because this isn't just fraction equal fraction. So when it's not just fraction equal fraction, you have to find the LCD and then multiply each term by the LCD. So in this case, I've got a 2x, a 5, and a 10x. So with 2 and 5, the LCD would be 10. And then I also have an x in 2 terms. So remember what you do is you take the highest power of any factor. So if I have an x and an x, the highest power is just x to the first. So my LCD is going to be 10x, which means that I'm going to multiply this whole equation, left side and right side, by 10x. So what ends up happening is, and I can write this out so you can see it a little bit more clearly maybe, you have 10x times 5 over 2x minus 10x times 2/5 equals 10x times 3 over x. And now the whole idea of getting an LCD is now all these denominators are going to cancel. So this x cancels with this x, and 10 over 2 would reduce to 5. Here, 10 over 5 reduces to 2, and the x stays. And here, just the x's cancel, and the 10 stays. So what you have now is 5 times 5, which is 25, minus 2x times 2, which is 4x, equals 10 times 3, which is 30. So now you have a very simple linear equation that you would solve just by subtracting 25 and then dividing by negative 4. So what you have is x equals negative 5/4. And again, is negative 5/4 going to make one of those denominators 0? No, only 0 is going to make one of those denominators 0. So negative 5/4 is a valid solution. All right. And then the last one. Now the last one is the one that caused the most trouble on this test, and I think the 1/6 is what threw everybody off. All right. So the first thing I would do is, again, realize that x squared plus 5x plus 6 is not going to be part of the LC, is not going to be one factor, right? This is going to break down into something. So what you want to do first is you want to factor this. So x squared plus 5x plus 6 reduces to, or factors into, x plus 3 times x plus 2. And now it's going to be much easier to deal with, right? Because now I can see, all right, what's my LCD? I've got an x plus 3. I've got an x plus 2. But I also have the 6, and I can't neglect that 6. I need to include that 6 in my LCD. So that's my LCD, which means that I'm multiplying both sides, or each term here, by that. And what I'll do is, to save space, I'll just write it in here by each term, because otherwise I'm going to run out of space. So you see what I did is I just wrote the LCD by each term to show that I'm multiplying each term by that LCD, and now I can do the cancellation. So in this first term, x plus 3 and x plus 3 cancel, x plus 2 and x plus 2 cancel, so I'm just going to have 6 times 1, which is just 6, plus, in the second one, the x plus 3's cancel, but that's it. So now I'm going to have 6x, x plus 2, and then in the right hand side now, the only thing that's going to cancel is the 6. So I'm just going to have 1 times x plus 3 times x plus 2. So now this is the equation I now need to solve. Right? What a lot of people did on the test is they forgot that 6. So they had like 1 plus x times x plus 2 equals, I don't even know, because then you wouldn't have gotten rid of the 6. So that's the problem. That's where you ran into the problem. You had to multiply the 6 also on each side. So now, I mean, this is not terrible. It's just going to be a good amount of work. So you got to distribute this 6x. So this is 6x squared plus 12x. And then this is going to be x squared plus 5x plus 6. So the nice thing here is if you try to, let's say, move everything to the left, subtract everything on the right side, line it up under what it's going to combine with, so you would just end up with 5x squared plus 7x equals 0. And believe it or not, this causes problems because people sometimes don't know what to do with this. But what do you do with this? You factor by the GCF. The only thing they have in common is an x. Take that out, and then you're left with 5x plus 7 equals 0. And now just solve these individually. So the left one is just x equals 0, and the right one is going to equal, subtract 7, divide by 5, negative 7/5. And here, you do have to be careful because a lot of times x equals 0 is an extraneous solution because it might make a denominator 0, but look at these denominators. The only things that are going to make this denominator 0 are negative 3 and negative 2. And neither one of these are negative 3 or negative 2. Therefore, those solutions are both valid. All right? So, that one, not many people got right on that second test. Right? And I think the 6 in that denominator is what threw people off. If that had been equal to 1 instead of 1/6, I think a lot more people would have gotten it right. But the 6 threw people for a loop there. You had to multiply everything by 6 also. All right, and finally, solving graphically. And this, some people just had no clue on this. But see, what I had mentioned back probably in the first unit somewhere is that this is very easy. Once you learn how to do it, it's the same process no matter what kind of equation you're dealing with, right? Solving graphically always means take one side of the equation and enter it into the calculator as y1, and take the other side of the equation and enter it into the calculator as y2, and then just find the intersection points. And I give you the window. So what you would do with this first one is you just go into the calculator and you'd say, okay, let's go to y1 and make it 2 divided by x squared plus 1 divided by parenthesis x minus 5. And I even gave you the parentheses so that you wouldn't mess it up. So that's your y1. And then your y2 is just going to be x minus 4, right? And I give you that window. So just push window. And what are these numbers? This is just the x min, x max, x scale by y min, y max, y scale. So basically you're just entering it down the list in order. So you would just do 0, 10, 1, negative 10, 10, 1, which is there. So now I just hit graph, and I just draw this. And here's my two intersection points. So my intersection points here are going to be, right, I have to do second trace, which is calc, number 5. And then first curve is just going to be your y1. Second curve is going to be your y2. And then when it says guess, move it close to the intersection, hit enter again. So there's one intersection. So 5.636. So x is approximately 5.636. And then I do the same thing now with my other one. I again go second trace, number 5, and then y1, y2, and then now my guess is over here, which is 3.498. 3.498, right? And then you would just give a little sketch of that graph. It's going to be hard because I can't see it, both things at the same time, but it looks something like this, this, and then this. And then here was your solutions. Right? Is that the best sketch? No, but it's not terrible. Right? You get the idea. So that was your solution to that one. And then again, like I say, once you know the process for this, every problem is the same. So the second one, there's your y1, there's your y2. So in this case, you make that y1, and you make this y2. So y1 here is going to be x plus 2 over x minus 2. Right, so I'll just clear this one out. So it's parenthesis x plus 2 divided by parenthesis x minus 2. Oops, sorry. Uh-oh. Alright, x minus 2. And then my other one is just x squared minus 5. And now I'm going to, it says graph in standard window. So standard window I can get to just by doing zoom 6, which is standard. So this actually has 3 solutions. Now you might look at this and you might say, oh, no, hey, there's 1, 2, 3, 4. But if you remember from that second unit, that vertical line there is really a glitch in the calculator. That's not really part of the graph. It's really undefined at x equals 2 because it makes the denominator 0. That's really kind of like a vertical asymptote, what's being drawn in there. That's not really part of the graph. So there's really only 3 solutions. So you would do calc, intersect, y1, y2. Here's the first one, which is negative 2.249. And I'm just going to 3 decimal places because that's what they wanted on the test. They'll pretty much tell you how many decimal places they wanted. So that's negative 2.249 to 3 decimal places. And then you do it 2 more times. So you do calc, intersect, and now enter, enter. But now when it says guess, you move it over by the second one, which is here, 1.146. So there's the other one, right? And a lot of people kind of had the idea with this, but they forgot about the third one. They didn't look to the right and realize that, hey, there's another one. So if I do calc intersect again, there's a third one up here, right? Remember, this one is not a solution because that vertical line there is really like an asymptote. It's not part of the graph. So that's the third solution, which is 3.103. So in this case, there's actually 3 solutions, right? And I'm not going to sketch the graph on this one because I'm just going to mess it up and make it look worse than the other one. So, but you get the idea. You would basically just sketch that graph that you see there, right? And again, it shouldn't give me a solution here. If I do calc intersect and I try to get a solution here, hopefully it won't give me one. Well, right, okay. It gives me the other one again. It shouldn't give me this one here. There should be no way that I can get that point because it's not really a solution. Right, okay, so then I went there and it gave me the other solution. So at least it works that way. It will not show that as an intersection point because it's not a legitimate intersection point. Because if you see, if you go to the table and look under y1, you see you have an error when x equals 2 because that's what makes the denominator 0. So there can't be any solution over there at 2. All right. But that was the idea. And again, once you get this down, and you should get it down by now because now we're at the third test, right? Once you get this down, it's down for any kind of equation that you're solving graphically. So whenever they say solve graphically, you enter one side as y1, the other side is y2, and then just find all the intersection points, and you're done. And you only want the x values, right? That's the other mistake people made. You don't want to give me the x and the y. These are equations that only have one variable, so you only give the x coordinate of the intersection point, right? Not the whole point, just the x coordinate. Okay? So that's basically it.